Thank you very much for taking the time to check this video. This video is concerned with Medical Environment Asset Management System means. This is submitted as a proposed solution for the General Electric Egypt Digital Innovation Challenge by a company called Telecom Wireless Advanced Services and Solutions, Tawassul for short. And what I will try to do today is to give you an overview of our proposed solution, its constituents, its advantages, and some sample windows from the proposed application. So the MEMS, or the Medical Environment Assets Management System, is an integrated operational solution for hospitals. It covers the medical equipment, the medical staff, and the patients. Now, for the medical equipment, we are able through MEMS to track its location, its operating status, so whether the equipment is switched on or off, its utilization, so how often is it utilized and by which departments, and the maintenance status and history to have the willingness of these equipment and whether they require maintenance at the time or not. Now, for the medical staff, we're able to provide the staff location, what are their tasks, assignments, and what are their working schedules, just to name a few of the aspects that are important from the medical staff perspective. For the patients, we are able to locate the patients themselves, what's their treatment schedule. They can request service and medical assistance through the application. And also we address one of the key problems in hospitals in Egypt in general, which is the external clinics, where it's very important for the patients to have idea about what's the schedule and what's their expected waiting time within these clinics. So the key idea of MEMS is the idea of public sensing. Now, before I go into the idea of public sensing, so we start from the sensing layer. And what do we have in the sensing layer? We have sensors that are able to sense location, sense temperature of equipment, sense electrical current of equipment. Now, for the location of equipment or the location of medical staff, this is how you localize them. Now, what is more innovative as an idea in this proposal is to utilize temperature and electrical current sensing of the equipment to be able to know its operational status, whether it's on and off, and also by checking these measurements that are relative to existing calibrated profiles of this equipment, we can have an idea about the willingness of this equipment and are they functioning well or not, and whether they need maintenance updates or not. Now, these data has to be relayed to the cloud for data processing and for decision making. Now, in order to be able to do this, we would require a network infrastructure in the middle. Now, the key idea of public sensing is to replace the network infrastructure, which is timely to deploy and also has a high cost, with the public sensing concept. So, what does the public sensing concept offer? Given that the hospital naturally has hundreds and maybe thousands of dispersed hospital staff all across the hospital environment, and they are most probably equipped with cell phones or tablets, then we would use their digital equipment and their MEMS application to interface between the sensing layer and the cloud layer. So essentially now we have an infrastructure of people rather than an infrastructure of hardware. So what are the key technologies that we envision? So at the sensing layer, we have a group of sensors. These sensors would relay their information through the Bluetooth low energy technology. The advantage of this technology is that it has a low cost and a lot of off-the-shelf equipment with long battery lifetimes in the scale of 2 years. And we will have two types of Bluetooth transceivers. Some of them are fixed iBeacons, and iBeacons is another name for the Bluetooth low energy that relays data, only transmits data and doesn't receive. So we would have fixed iBeacons, so these are anchor points in the hospital, which means that they are installed at fixed locations. And we would also have mobile iBeacons with sensors, and these are tagged to the medical equipment to track the equipment location and also to track the operational status of these equipment. Now, at the public sensing interface through the cell phones and the tablets, this is what holds the MEMS application itself, but it also relays the iBeacon readings towards the cloud. And at the cloud layer, using the Predix technology of GE, we will be able to do the data analytics and processing. So more specifically, the fixed beacons of the Bluetooth low energy technology are installed into fixed locations across the whole hospital. And their main job is for localizing staff cell phones and tablets. So based on predefined locations of these beacons, we are able to identify the location of the tablets or cell phones that are seeing these fixed eye beacons. Now, the next components of the proposed solution is the cell phones and tablets. As I said, this is what holds the MEMS application, but it also sends the beacon readings of fixed beacons towards the cloud through Wi-Fi or cellular. It can also send the beacon readings of mobile beacons for temperature and current localization updates from equipment, which leads us to the mobile eye beacons. So the mobile eye beacons are the beacons that are attached or tagged to the medical equipment. And their job is to localize or to find the location of this mobile equipment. And this will be done, as we'll show in the next slide, relative to active cell phones and tablets, and to relay the sensor information for temperature, current, and maybe also accelerometer measurements for equipment operation, monitoring, and location. And at the end, at the Predix cloud level, we have the data analytics and decision making. So this slide gives a clear overview of the idea of fixed and mobile beacons and the means operation in general. So let's take, for example, these red beacons. So these red beacons are essentially Bluetooth low energy transmitters. They are fixed at fixed location across the hospital. So we know their coordinates. And now let's take, for example, this mobile or this tablet. So this mobile tablet is receiving at the same time signals from one, two, 3, and 4 fixed eye beacons. And therefore, we are able to localize this tablet or this cell phone relative to the locations that is predetermined for these beacons. Now, by doing this concept, running these algorithms for all the mobiles or tablets in the hospital environment, then we have the location, or we're able to identify the location of all the medical staff within the environment. And this could be relayed through Wi-Fi or cellular to the cloud or the database. Now, the blue transceivers or the blue beacon shown on this slide, these are the ones that are tagged to the mobile equipment. And these not only do they send identity information, but they also send temperature and current electrical current drone information. And given that these fixed beacons in this proposed system are only transmitters, so we will utilize the dispersed cell phones and tablets in the environment to receive from these mobile eye beacons. So let's take, for example, this cell phone, and suppose we have already identified the location of this cell phone. Now, given that we have identified the location of this cell phone, and this one as well, and this mobile eye beacon is received here and received here, then we can calculate by the localization algorithm the location of the blue mobile beacon relative to the location of these tablets, which has been calculated relative to the fixed anchor points. And what we see as dashed lines is that actually also these mobiles can collaborate. So they can exchange information about what they are seeing to be able to support the localization system. Okay. Now, what are the advantages of the proposed solution? I have already highlighted that one of the main advantages is that it's a low-cost, fast deployment solution. It has minimal infrastructure requirements. So at the sensing layer, we're talking about low-cost off-the-shelf eye beacons that are already equipped with temperature, current sensors, and accelerometer sensors that could help for localization. And these are at the scale of below $10 per beacon. And therefore, we would require minimal infrastructure to support such system. Now, the public sensing interface is an integrated platform for different staff members, whether it is the doctors, the nurses, the technicians. So all of them are aggregated over the same platform. And also the public sensing concept offers redundancy because we have multiple alternatives to collect data and relay them to the cloud layer. Now, at the cloud layer, we will highly benefit from the powerful Predix tool, and in the report, there are more details about this, but we are proposing that you can use the connectivity, time series, location intelligence, intelligent mapping, and dynamic mapping, just to name a few of the tools that are associated with the Predix cloud environment. What I would like also to give, just to give a feeling of the application, so I'll take you through some sample screens. So this is an example of a registration screen, and as I said, this means is an integrated solution. So what we have is that you can identify a medical staff, a technical staff, or a patient, and then with the registration you can have the name, the department, and you can have For example, for the equipment, you can see who's the Doppler equipment is under the responsibility of this individual, and who's his supervisor and who's he reporting to. For operation, let's take the equipment as an example. So in this screen, what we can see is that there is an electrocardiograph machine number one, and this is the model of it. And you can have identify where is its current location, whether it's on or off, and actually also if it's needed at some department, you can request and you can assign a certain priority to this request. Now you can always, from more information, have more information about any of these features. Now you can also have the equipment as a map view. So for this equipment, we can have a map view to see where is it located currently. So here it's in Word F1. Another example from the clinic's perspective, and as I said, we are targeting one of the main problems in some hospitals in Egypt is the external clinics. And here we have Dr. Ahmed, and what is his specialization, what is his working schedule for a given day, and the current status. So he's now checking patient B5, and actually under more information, maybe we can identify our waiting time and other information if needed. And also we can rate the doctors so that you have a global database of the doctors and the recommended doctors within this hospitals from the patient's point of view. So once again, I'd like to take the opportunity to thank you very much for viewing this video. And it means we believe that hospital operation health through digital technology is the patient's well-being.